Hello, my name is Autumn Haven, and welcome to Super Science Sunday. Today, we are going to be making our own DIY homemade lava lamp that does not include heat, so it's completely safe. Now, before I begin, I would like to thank you very much for watching this video, and I hope you learned something new today, and welcome to the channel. So, here you go. Now, to begin, you're going to need vegetable oil. Sorry, this container is empty. My family is now out of vegetable oil. A funnel, food dye, water, and some sort of bottle or container or something. This one specifically already has the oil in it, but this one specifically used to be a honey container, and I like it because it has two smooth, easy to see through sides, a lid that goes with it, and it's quite thin but still thick this way, so you're saving materials. You don't have to use as much vegetable oil. And then finally, you're going to need Alka-Seltzer tablets. This wasn't meant to be in the presentation. Now, to begin, fill up your oil about 3/4 of the way, maybe 7/8. None of this has to be an exact measurement, by the way. But fill it up. In my opinion, I basically take your hand, cut your hand in thirds, like draw lines, put it in thirds, and then that last section, fill up that much worth of water. That's my kind of rule of thumb, rule of hand. Now, you're going to take your dye and your water, and dye your water whatever color you want with your food dye. Whether it is, in my case, I always choose blue. It's very clear and easy to see on camera. You can choose green, red, whatever. It doesn't really matter. What? Oh, I have food dye on me now. Now, make sure... pick up a cloth I have down here. There you are. Now, make sure that you have enough dye in it that it gives it a nice, good color. Yeah, like that. Like a really deep, nice color. Keep that right there just in case. Now, you're going to add the rest of your water. Now you're going to add water to this until it is full. Use your funnel for this. Don't care how steady-handed you think you are. This will prove it. You're going to notice the water instantly sinks to the bottom. That's a good thing. You want that. Now, take an Alka-Seltzer tablet. They normally come in big boxes, and then each are individually wrapped in, like, wraps of 2. So you can see the little Alka-Seltzer thing. And then when you open it up, there are 2 in here. Now you're going to take one, you're going to want to break it up into a few smaller pieces. So I am breaking into like 8s, and then drop an Alka-Seltzer tablet in each piece, like one at a time, and watch the reaction go, okay? A bunch of bubbles should start raising to the top with the water in them. You see? Just like a real lava lamp. It's crazy. I'll put the last one in. It explodes to life. Crazy, isn't that? Absolutely crazy. Look at that. That's bonkers. Absolutely cool. So, oh no, it's about to overflow. Oh no. Oh no. As I say in other experiments, in this case, it's not exact science. It's really just working right through it, and I normally only do like 0 to 1 test runs before I actually make these videos. But yeah, I'm good now. I think we're good now. But yeah, so that's it. That is the experiment, and now I'm going to tell you the science behind it right after this cut. This lava lamp works because of 2 different scientific principles: density and polarity. Density is the measurement of how compact a substance is, how much of it fits in one certain amount of space. If you weigh an equal amount of oil and water, you'll find that the water is heavier than the same amount of oil. This is because the water molecules are more tightly compact together. A cup of water actually has more mass than a cup of oil. For example, a piece of wood is much denser than a sponge. Because water is more dense than oil, it will sink to the bottom when the two are put in the same container. Now, density is also affected by temperature. The hotter a liquid is, the less dense it'll be. But I'll explain more about that later. The second reason why a lava lamp works is polarity. Polarity is the property of having magnetic poles. Water molecules have polarity because they have a lopsided electrical charge that affects other atoms. One end of the water molecule has two hydrogen atoms that are positively charged. The other hand has one large oxygen atom that is negatively charged. Hence H2O. Just like a magnet where the north poles and opposite poles attract, the opposite end of a water molecule connect to the negative end of a molecule. The negative end of a water molecule will attach to the positive end of another molecule. Oil molecules, however, do not have polarity. They do not have a positive or negative charge, so they are not attracted to the water molecules at all. This is why the oil and the water do not mix. The water stays to the bottom and does not mix with the oil, except for a few bubbles mixed in there. We also put Alka-Seltzer tablets into our homemade lava lamp to make it bubble, if you remember correctly. The bubbling happens because the Alka-Seltzer reacts with the water to produce carbon dioxide gas bubbles. These stick to water droplets. The water-gas combo is less dense than the oil, so they rise to the top of the flask. Then, at the top, the gas bubbles pop and escape into the air, allowing the now more dense than oil water to sink back below the oil. Real lava lamps use polar and non-polar liquids, just like our homemade one did. In real one, however, the densities of the liquids are much closer together than vegetable oil and water. The densities are much more similar. Just like in ours, the denser liquid sinks to the bottom, but instead of bubbles lifting it up, the light at the very bottom of the lava lamp, under the, all the juices and stuff, heats it up until it expands and becomes less dense than the other material, thus rising to the top. And then as it's rising to the top, it loses heat, cooling down, becoming more dense again. Now, this is what causes the bubble and the cool effect in real lava lamps. Our little guy is just running off with chemicals. Now, thank you for watching this video. I hope you have a great day, and see you next video. Well, Sunday, I should say.